Hey guys, so I just wanted to pick up where we left off with the elimination method for solving systems of equations. In class, we had already done a couple easy examples where our system already had opposites on either our x variables or on our y variables, and we were ready to just go ahead and add our equations like they were. So now we want to look at some examples where our equations don't quite have opposites yet, and we have to create opposites. So if you look at this system right here, if we look on our x variables, we have a 5 and a -2, so those are not opposites. And on our y's, we have a 3 and an understood 1, and those are not opposites either. So when that happens, what you need to do is you need to multiply one of the equations by a constant to create opposites. So is it going to be easier to multiply the -2 by something and create the opposite of 5? Or is it easier to multiply the 1 by something and create the opposite of 3? So since there's nothing to multiply 2 by to get 5, or at least not a whole number, it's going to be easier to multiply a 1 and get a 3. So if we can take this entire bottom equation and multiply it by -3, we can create a -3 on this y, and then we'll have opposites here. And when you do this, that -3, or whatever you're multiplying by, has to go to every single part of the equation. So I'm going to rewrite the whole system out here to the side. That top equation stays exactly the same. The bottom equation changes completely to 6x minus 3y equals -33. And now you're ready to add the equations. So the x's, when you add those, becomes 11x. The y's eliminate because they cancel out. And then you add your constants and you get -44. And then you solve this by dividing both sides by 11. And so x is -4. And then you need to plug that back in to get your y. And when you plug back in, you always plug back into one of your original equations, not a new equation that you created. In case for some reason you messed up creating one of the new equations, you always go back to the original. So I'm just going to use this one up here and put the -4 in the x spot. So you have -20 plus 3y equals -11. I'm going to add 20 to both sides. So I have 3y equals 9, and then divide both sides by 3, so y is 3. So my solution for this system is the ordered pair, -4, 3. So if I wanted to check that, I could graph and see if they intersect at -4, 3. Okay, for the next system, you'll notice that they're not quite lined up the way they should be. We want our x's lined up vertically, and then our y's, and then equal sign, and then our constant. And our bottom equation is not quite in that form. So to get it in the right form, we need to move this -4x over to the front, and since it's coming across the equal sign, it will become positive. So let's just rewrite this whole bottom equation. If we move the 4x over, it's going to become positive. We want to keep the 6y on the side that it's on. We want to keep the 12 on this side. So it'll look like that when we move it over. We can just get rid of that equation altogether. Okay, so now they're lined up the way they should be. Let's check and see if we have opposites. We don't. On our x's, we have a 2 and a 4. And on our y's, we have a 3 and a 6. So we want to create opposites. We can multiply the 2 by something and try to get a -4, or the 3 and get a -6. It's about the same either way. So take that top equation, multiply by a -2. Let's rewrite it. So we're creating a -4 on our x to make opposites right here. That's going to give us a -6 on our y. And that's going to give us a -12 for the constant. And then our bottom equation stays the same. And now we're ready to add. Okay, so what happens here is our x's cancel. They eliminate. Our y's also eliminate. So we actually created opposites on both of them. So 0 on this side. Our constants also eliminate, 0 on this side. Okay, so we talked about this in class, how when your variables go away altogether and you're left with just numbers, It's either going to be a no solution, which means you have parallel lines, or it's going to be infinite solutions, which means you have two of the same line and they lay on top of each other. The way that you decide which one it is whether this statement is true or false. So in this case, 0 is equal to 0. This is a true statement, which means these are the same lines. So this is infinite solutions. Okay, and now for the hardest problems. All right, if you look at this first example, we have a 2 and 5 on our x's, and we have a 3 and a negative 10 on our y's. There's not a nice whole number we can multiply 2 by and get 5. There's also not a nice whole number we can multiply 3 by and get 10. So when this happens, we end up having to multiply both equations by a number. So you can kind of decide whether you want to get your x's to eliminate or your y's to eliminate. And it's just personal preference. So let's say that I want to get my x's to eliminate. Okay, so if I'm looking at my x's, 2 and 5, what I want to think of is the least common multiple of 2 and 5. In other words, the smallest number that 2 and 5 will both go into evenly, which in this case would be 10. So I want to create a positive 10 out of one of those equations and a negative 10 out of the other. Okay, so if I want my top equation to have a positive 10x, I would need to multiply that 2 by 5. So the top equation is going to get a 5. And if I want to make a negative 10 as my coefficient on the bottom equation, I would need to change that 5, or I need to multiply that 5 by a negative 2. So that whole bottom equation gets a negative 2. So I'm going to have two brand new equations. So let's write those out. Multiply the whole top by 5. It's going to create 10x plus 15y equals negative 80. And then the bottom equation, when I multiply by negative 2, is going to create negative 10x plus 20y equals negative 60. And now I'm ready to add. So when I add, the x's eliminate. I get 35y, and I get negative 140 for my constants. And then we need to divide both sides by 35 here to solve for y. And y is negative 4. Okay, and then you're going to plug back in to get your x. Doesn't matter which equation you use, but always make sure it's one of the two originals, not one of the new ones. So I'm going to use the top one. So we'll have 2x plus 3, and you're going to put negative 4 in there for y, equals negative 16. So that's 2x minus 12 equals negative 16. You want to add the 12 over. 2x equals negative 4 and divide by 2. X equals negative 2. So our ordered pair is negative 2, negative 4. Whoops. Negative 2, negative 4. Okay, and then our last one, same situation. On our x's, we have a 3 and a 5. And on our y's, we have a 2 and a 3. There's no nice whole number I can multiply 3 by to get 5 or 2 to get 3. So we're going to have to multiply both equations. So since we eliminated the x's over here, just to make this one different, let's try to eliminate the y's over here. So we're looking at 2 and 3. We want to find the least common multiple of 2 and 3, which would be 6. 6 is the smallest number that 2 and 3 will both go into. So we want to make one a positive 6 and one a negative 6. So if we want to turn this 2 into a positive 6, we would need to multiply it by 3. To change this 3 into a negative 6, we would need to multiply by negative 2. All right, so we're going to get two brand new equations. The top equation would be 9x plus 6y equals 24. And the bottom equation would be negative 10x minus 6y equals negative 20, and then you're ready to add. So when we add our x's, we're going to get negative 1x, or just negative x. The y's are going to eliminate. Add your constants, you're going to get 4. You need to divide by -1 to get rid of that negative, so x is -4. Okay, then we want to plug that -4 back into one of our equations. I'm going to use this top equation right here. So we have 3 times -4 plus 2y equals 8. So -12 plus 2y equals 8. Add your 12 over. So 2y equals 20. Divide by 2, y is 10. So our ordered pair is -4, 10.